So now let's see how we can bring all of the things we've been talking about so far: concavity, increasing, decreasing, relative extrema. Let's see how we can bring all this together and use it to sketch the graphs of functions. Right? In this lecture, we're going to look at some things we're already familiar with. We're going to look at polynomials and rational functions. Then in the next section, we'll kind of take it a step further, and I say that because we already have lots of tools for graphing those kinds of functions. Then in the next lecture, we'll look at some kind of more complicated things with exponential functions and logarithms, and maybe some more complicated trig functions. So we kind of have a process that we can use to do this, and we'll mix and match here. We won't use all of these every time. When you're first starting out, it doesn't hurt to really kind of work the list and go through all of them. All right, so let's talk about this real quick, see what we're going to do. First, we're going to look at the domain. Right? If a function has a logarithm or something with a restricted domain, that's going to let us eliminate a whole section of the plane right off the bat. We're going to look at intercepts. We're going to look at asymptotes. We're going to find the derivative and use that to find relative extrema, where the function is increasing and decreasing. Then we can look at the second derivative. The second derivative is something. This is a step that honestly we'll often skip over. Depends on the level of detail you need. Sketching concave up versus concave down can be a tax on someone's artistic ability, especially mine, since it's pretty limited anyway. But we do have that tool if we need it. And finally, we may need to plot points here and there to decide if a function is above an asymptote or below it in certain areas. So let's take a look. Pause if you need to, if you're writing this down, taking notes. Then start it back up and we'll look at some examples. All right, so start off really basic, polynomial, right? And let's see, what do I know about this thing? I know the domain of a polynomial is always all real numbers. And let's see if we can find its intercepts. To find the intercepts, I need to take the function x cubed minus 3x squared minus 9x plus 3 and set that equal to 0. And I think I can factor this. I can do a little factoring by grouping. I'll make this x squared times x minus 3 minus 3 times, oh, that doesn't work, does it? Oh, I was hoping it would. Okay, well, maybe we can't find the x-intercepts. Right, this is what I was talking about earlier. Right, sometimes we'll have to skip over some of these. It probably has some, but it doesn't mean we can find them. However, we can, because this is almost always relatively easy to do, we can find the y-intercept. Right, the intercept is y equals f of 0 equals 3. That's going to be here. Okay, so now let's go to the calculus bit. Right, let's find the first derivative of this. F prime of x is 3x squared minus 6x minus 9. And I'll set that equal to 0. And let's see, let's get rid of the, divide everything by 3. X squared minus 2x minus 3 equals 0, and that factors. X minus 3 times x plus 1, and I get two critical values, negative 1 and 3. So let me do a number line here, negative 1 and 3. And let's see, what are we going to test? Let's test negative 2, 0, and 4. If I put negative 2 in, I get negative 5 times negative 1, which is positive. And if I put 0 in, I get negative 3 times positive 1, which is negative. And if I put 4 in, I get 1 times 5, that's positive. Right, so the function increases and then decreases. So I have a relative maximum at -1, and then it decreases and then increases. So I have a relative minimum at 3. Okay, now when you're doing these, we're sketching. I mean, you could put -1 in there. That's not going to be too bad. F of -1 is, let's see, that's -1 minus 3 plus 9 plus 3. That's 8. So F of -1 is up here. And which one was that? That's the maximum, right? So let's do the other one first. Let's do 3. F of 3. Let's see. That's going to be 27 minus 27. Got minus 27 again. 27. Minus 27 minus 27 plus 3. That's -24. Now look, don't obsess over getting this. I mean, -24 is down off the bottom of the page somewhere, right? So all I know is that there's a minimum down here. This is -3. It's down here somewhere, right? That's fine. Okay, these polynomials, as the degree gets even moderately high, 3 is not that big, the values can already get pretty extreme. So this is good enough, right, for my graph. It's going to look like this. It's going to come up, turn around and come down here, and turn around and take off. There's my graph. That's accurate enough for sketching purposes. So let's take a look at this one. You can pause this if you like. Take this one and see what you can do with it. Then I'll go over it. All right, so let's see. First, we're going to talk about domain. Well, it's a polynomial, so it's obviously all real numbers. Domain, all real numbers. Then X-Intercepts. I don't know. X to the 4th minus x squared plus 2 equals 0. That doesn't factor, right, in any obvious way. You could do a little substitution. That's a quadratic, right? It's kind of got the form of a quadratic. You could let u equals x squared, use a quadratic formula. Okay. It may not be worth the trouble. Let's go on. Sometimes I'll skip something and maybe circle back to it if it looks like it's warranted. But for now, let's hold on to the x-intercepts. The y-intercept, y equals f of 0, that is 2. It's going to be here. All right, so let's do the derivative, let's do the calculus bit. F prime of x is 4x cubed minus 2x equal, that's the derivative, 4x cubed minus 2x. And to find the critical points, I'm going to set this equal to 0. All right, so let's see. I can factor this. Let's take out a 2x times 2x squared minus 1 equals 0. So I get 3 points to look at. First I get, if I set 2x equal to 0, I get 0. And if I set 2x squared minus 1 equal to 0, I get plus or minus the square root of 1/2. All right, so let's do some tests. All right, I've got to put negative square root of 1/2. I have to put 0 and positive square root of 1/2. So let's see. Square root of 2 is 1.4. 1 over 1.4 is about 2/3. You can get your calculator out if you want to be more precise. I'm going to pick negative 1, negative 0.1, 0.1, and positive 1. All right, so if we test these, if you put 0 in there, if you put negative 1 in there, you get negative 2 times 2 minus 1. That's 1. So this is negative. If you put negative 0.1 in there, you can check me on this. If you put that in there, you're going to get a positive number. 0.1 gets you a negative number, and 1 gets you a positive number. All right, so this is decreasing and then increasing. So there's a minimum at -1/2. Then it increases and decreases. So there's a maximum at my y-intercept. And then it does the reverse again, decreases and increases. So here we have a minimum. All right, so let's put these together, right? What is, can we do it? Yeah, we can do f of 1/2 pretty easily. F of, the square root of 1/2 is the square root of 1/2 to the 4th minus the square root of 1/2 squared plus 2. So that's 1/4 minus 1/2 plus 2. So let's see, 1/4 minus 2/4 plus 8/4. That is 7/4. Okay, 7/4. 7/4 is just a little bit less than 2. Okay, so it's going to be, this is going to get scrunched in there pretty much. Well, let me get, just a second while I go to my calculator. What is the square root of 0.5? Let me get an exact number here. 0.5 square root. That's 0.7, 0.707. So that's just about here. And it's going to be there. And then here on this side. Yeah, I did the negative one, right? Notice, another thing that's useful to notice with these things, notice that that function is symmetric with respect to the y-axis, right? All of the exponents are even, right? So I knew if f of the square root of 1/2 was something, f of negative the square root of 1/2 had to be the same value. And this gives me what I need. Right, I'm going to decrease, and then increase, and then decrease again. And there's my graph, right? That's what this thing is going to look like. So that's polynomials, and they're pretty straightforward, but we had a pretty good handle on how to graph polynomials already. You probably did. So really all we added here was finding the maximum and minimum values, kind of pinning those points down. So in the next lecture, we're going to do something similar. We're going to kind of continue working our way up. We're going to look at rational functions and do the same thing there. Then, as I mentioned earlier, in the following lecture, we're really going to kind of go into territory where we had no real significant tools and talk about things like logarithmic and exponential functions.